Hello again, time for a little extension on amine formation and what happens when you let the reaction continue. The basic reaction, which is here with ammonia activated by its lone pairs, making it into a nucleophile, comes in, substitutes, makes a, well, some debate about what names you would call it. So you see the thing here says re-substitution. We'll get onto the re-substitution bit in a moment. Need to get the basics sorted first. So aminoethane, you will see it called. Ethylamine or ethylamine, you will also see it called that. I'm going to go with this name here for some of the things that we talk about, but actually its proper name is ethanamine. But we never called it that at A-level chemistry, but that's its IUPAC name. So I'm going to go with the one in brackets for much of today, although you see this one quite often as well. I put a number on there and then rubbed it out because it can only be on the end. Can't be on position 2 because it's going to be recounted as 1. The mechanism which comes out of the previous mechanism video, NH3 goes in, Br kicked out, transition state where one's coming in, one's coming out. It's an SN2 mechanism because this is a primary halogeno. And then an ammonia comes along, plucks off H as H plus and the electrons go down and you form the ethylamine. Other names are available. So that basic mechanism for some A-level courses is enough. But in some A-level courses, you're going to have to check if you're looking at this from the aspect of what's my A-level course got. I'm not going to tell you. You're going to have to go and check in your specification. Some of them do the following. This, which of course has a lone pair, can take the place of the ammonia in this reaction, and instead of ammonia doing this, this will react with the bromoethane, and that's where the re-substitution comes in. So I will take you through the re-substitution steps when I've got them on the board. I'll see you in a moment. Okay, so when we get onto the re-substitution part, what happens is the amine that we produced in the initial first substitution takes the place of the NH3 in the substitution mechanism. So its lone pair in there kicks out the bromine. You get this here. Now it's looking quite complicated, but what it is that is CH3, CH2, NH2, and then there's another ethyl group attached to the nitrogen because this is this one here, over here, and because you've got 4 bonds on the nitrogen, it's got a plus charge. So there, and then you could use this to pluck that off, but I'm using ammonia because there will be ammonia around because it's the initial setup is to put ammonia in with the bromoethane, and it will pluck off the hydrogen and you'll get this. So this nitrogen now has CH3CH2, which I've written slightly cumbersomely, but CH3CH2 attached to the N, a hydrogen attached to the N, and CH2CH3. So that's an ethyl. CH3CH2 is also an ethyl, so it's sometimes called diethylamine, more correctly called N-ethyl ethylamine. So it's ethylamine, and then the N, this means the N has been substituted with an ethyl. So it's N-ethyl ethylamine. More complicated mixtures you could get different. You could have a methyl and an ethyl, something like that. But it doesn't end there, because this has of course got a lone pair. So this can then go round and take the place of this in a further substitution. I will put that on the board. I'll just sort the board out. I will see you in a moment. So here we are with the product of last time behaving as the nucleophile. In it comes, out goes the bromine. We now have CH3CH2 and another 2 of the ethyls attached with the extra hydrogen making it a plus. H is removed as H plus, making an H4 plus. And we now have CH3CH2, which is an ethyl, there's an ethyl, there's an ethyl, it's triethylamine. Or, more correctly, N comma, what's a bad looking comma, N comma N hyphen. Now that breaks the old ruley thing of only get a hyphen between numbers and letters. Oh, life gets complicated the more complicated your organic substances get. N comma N hyphen, so NN diethyl ethylamine. So it fits the same sort of structure as last time, but we now got two extra ethyls on top of the original ethyl. So there we are. No! It's not over. This has still got a lone pair. It's going to take the place of this. I'll get the board ready for that, and I'll see you in a second. So here we are with the last time. We can't do it again. Here's the product from last time. In it comes as a nucleophile, out goes the bromide ion. We then have the nitrogen with 4 ethyl groups attached. There's an ethyl, CH3, CH2 there, and 3 more there. And that's it. It doesn't do any, there's no hydrogen to remove. There is no longer a hydrogen attached to the nitrogen. We've replaced them all and used its lone pair. So it is now CH3, CH2, that's the ethyl, 4 times, 1, 2, 3, 4, N, plus charge, pairs up with the bromide, because we were using there. If you were using a chloride, it would pair up with the chloride. If it was an iodide, you'd get an iodide salt. So this is called Tetraethyl ammonium bromide. So what that means is that ammonium, which is NH4 plus, H's have been replaced by 4 ethyls, tetraethyl ammonium bromide. The type of compound which you also need to know is called a quaternary, means for quaternary ammonium salt. But my last thing to say is that remember to check your specification, because if this is not in your specification, thank you for watching, but you didn't need to. If it is in your specification, make sure you've got it all written down and you've understood it. I am going to try to write some questions for this. I have to say I haven't thought about the questions when I made the video because I was on a bit of a short time schedule to get this done. But I'll have a go at writing some questions in the near future for this. Resubstitution on ammonia using the produced amine as a nucleophile, all the way up to completely replacing all the hydrogens and then using the lone pair. Quaternary salt, end of the sequence. Thank you for watching. I'll see you for another video soon. Goodbye.